Sir, please begin. We are live.
Yes, sir. Okay.
Sir, please start the session. Sir.
Hello, I am not getting you. Hello.
Sir, please start the session.
Okay, thank you. Welcome all of you. I warmly welcome Dr. Nilesh Mistry, sir. Nilesh Mistry, sir, is Chief Technology Officer in Lonson Kiri Industry Limited, and sir has vast 30 years of experience in different leading industries like Atul Limited, Atlas Dye Chemicals, Sajjan India Limited, Solaris Chemtech Limited, Bayer India Limited, Huntsman Limited, and Lonson Kiri Industries Limited, which is current assignment. Sir has vast knowledge about drugs and dyes, and he is I can say he's an ocean of the knowledge regarding dye, drug, chemical intermediates, and technologies of the industry. So I would like to request sir to please start the webinar on the topic, that is challenges of dye stuff industry.
Thank you, Dr. Dev. I hope I am audible clearly.
Yes, sir.
Okay. So can I start?
Yes, sir. Yes, sir.
Okay. So good afternoon and welcome to all the participants. Myself, Dr. Nilesh Mistry, working with Lonson Kiri Chemical Industries as Chief Technology Officer since nearly 10 plus years. So I have got an opportunity to interact with the students. So let us start. So my topic for the today's presentation is challenges of dye stuff industry. So what challenges dye stuff industry is facing and how to overcome these challenges. So I'm going to talk on this subject. So our vision at Lonson Kiri or Kiri Group of Industries is we strive to be the environmental and innovation global leader in synthetic organic chemistry category. Now you can see the picture. Now I mostly show this picture of our Honorable Prime Minister and the Chief Minister at the inauguration time of Lonson Kiri, who kindly inaugurated our organization and motivated us to continue these manufacturing activities. So this is the Lonson Kiri entering view. Now we can go to the main content of the presentation. So I have divided the total presentation in 7 categories. Number 1 is understanding of dyes and dyes intermediate industry. The number 2 is chemistry of sulfonation. I have taken only one unit process as an example. Then the diazotization, the main reaction in dye chemistry, and coupling, diazotization and coupling. The difference between the dye industry and pharma industry. The methodology, what European industry and Japanese industry is following, that I am going to show you. The best chemistry principles for best output of the required yield and quality. Then comes the ethical and improvement challenges which every industry is facing and taking care of those challenges. And the last one is how Lonson Kiri has implemented all above 6 points and accepted the challenge and progressed like anything. So let us go to main seminar one by one. Number 1 is understanding of dyes and dye intermediate industry. So see, the growth of textile industry has a direct impact on the growth of dye stuff industry. Means textile and dye stuff industries are interlinked or linked with each other. And as we all know, the textile dye stuff has a wide market of 5.7 US billion in the year 2018, which is, and the largest category are reactive and dispersed dyes, which is about 44% of total dyes market. Asia Pacific region represent the nearly 40% of the global dyes market. The global dyes market has gradually shifted from Europe, Japan, and USA to Asian countries like China, India, Bangladesh, and this kind of Asian countries. Now, as we all know, China is the largest manufacturer of dyes, followed by India. India is at number 2. And India has a 16% of total share of total world dyes and dyes intermediate production. India also is a leader in the production and export of reactive dyes, whereas China is the largest producer of dye intermediates, dispersed dyes, and azo dyes. Indian dyes industries plays a vital role in the economic development of the country, and dyes industry is the second largest export segment in the chemical industry in India. If we see of India, Maharashtra and Gujarat account for nearly 90% of dyes production among the total dyes produced in India. Now, if you see the graphical presentation, total top export destinations for Indian dyes. So India is exporting worldwide. So the major export countries are USA 8%, 7% Turkey, 6% Bangladesh, nearly 5.7% China, 4.6% Germany, 4.3% Italy, 4.1% Brazil, 3.9% is Brazil, 3.7% Netherlands, 3.3% Indonesia, and the rest of is nearly other 50%. Now, if we see the value exported by India product wise, we can see that reactive dyes and pigments are on the top of the export products. Now, if we see the Indian domestic dye industry, we can see that out of total Indian dye production, 56% is of reactive dyes. Then comes 18% dispersed dyes, 15% acid dyes, 7% azo dyes, and remaining 4% is a mixture of other dyes. If you see here, we can see that in year 2017, out of total 205 metric tons, 205,000 metric ton per annum, 121, nearly 60% was of reactive dyes. If you see major intermediate producers and dyes producer in India, we can see this is the list of major dye intermediate manufacturers like Bodal Chemical, Kutch Chemical Industry, Kiri Industries, Colortech Industries, Jai Chemical, Akshar Chem, Ambuja Intermediate, Bagaria Industries, Mayur Dye Chem, Shri Pushkar Chemical. These are the major players in dyes intermediate, means the raw material of dyes they are producing. And the final dye producer, we can see Colortech is leading with Jai Chemical, other company, Atul Limited, the original pioneer of dyes in India in the year 1956. Kiri Industries, Lonsan Kiri Chemical Industries. Kiri Industries and Lonsan Kiri are the joint venture. So Kiri is also independent company. Lonsan Kiri is another joint venture company. Bodal Chemical Industries, Asiatic Color Chem Industry, and Shri Pushkar Chemical. These are the major dyes manufacturer in India. Now we can go to the second segment of the presentation, that is chemistry of sulfonation. Here we can see that for sulfonation is a major reaction for dyes intermediate structure. So we can do sulfonation with sulfuric acid or liquid SO3 or oleum, that is the fuming sulfuric acid. So how sulfonation takes place, that all MSc students nearly know that what is the mechanism of sulfonation. I have just here shown one structure of sulfonation of phenol. Here I have shown the sulfonation of 2-naphthol, beta-naphthol. So if we take beta-naphthol and do sulfonation with sulfuric acid under mild condition, it will attach to position number 1. Then on further sulfonation with sulfuric acid at higher temperature, it will attach on either number 6 or number 8. And then on further, like on stronger condition like higher temperature or more molar ratio, it will attach to disulfonation, and at the end trisulfonation also takes place. Now let us see what is diazotization. Diazotization and coupling are the major reactions for dye chemistry. Now let me explain you in short what is diazo. Diazo means two nitrogen atom, this two nitrogen atom, and when combined with this positive ion, it gives diazonium ion. Diazonium ions are produced when an aryl amine like primary amine like aniline react with cold nitrous acid. Now why nitrous acid forms? Nitrous acid is unstable, and based on the reaction of sodium nitrite with HCl at 0 to 5 degrees centigrade, nitrous acid forms, and it will react with this amino group and convert into diazonium chloride, which is very much reactive compound, intermediate we can say. Now it is diazonium compound coupled with any coupling component like aniline or phenol, which I am going to show you next slide. So it will attach either on ortho position or para position based on the their ortho para directing capabilities. So phenol and aniline both are ortho para directing raw materials. So here we can see that mechanism of coupling of benzene diazonium chloride with phenol in para position. So this diazonium chloride coupled with phenol and forms this diazo product. In this case, mechanism coupling with aniline itself. So benzene diazonium chloride couple with aniline and make this diazo product. So this is the general idea of diazotization and coupling. This is the structure of a dye which is produced by diazotization of K acid coupling with meta-uridoaniline, which is condensed with cyanuric chloride, and on the second chlorine is condensed with beta-base vinyl sulfone. So this is the general understanding of diazotization and coupling I have explained. Now we are going to see the chemistry of reactive dye. See, this is the structure of reactive black 5 dye. Now this is the basic dye. Out of total or majority reactive dye, this is the most required dye any dye industry is producing. Now this is a direct connection with what I am going to explain you in coming 2 slides, like the methodology of European dyes and methodology of Japanese dyes industry. So I have taken the example of the black 5 dye here, and I'm going to explain you what is the difference between European and Japanese dye industry. You can see that here I have shown the production sequence of black 5 dye. So the first step is diazotization of vinyl sulfone. Then second step is acidic coupling of vinyl sulfone diazo with H acid at 1 to 1.5 pH. Then comes the alkaline coupling of the same vinyl sulfone diazo with monoazo, means acidic coupled dye at 5 to 6 pH. So we can get the final black 5 dye. Now what European dye industry is following, that during first step they emphasize that the pH is correct, they like 1 to 1.5 pH. They also in second step they emphasize that free acid after first coupling should be in limit. Then the maximum 0.5% should be the free H acid should be there. They test this by HPLC. During second coupling, they said that free H acid should be in this limit, free monoazo should be maximum 2%, and pH should be 5 to 6. So the European dye industry emphasize more on this in-process testing, raw material quality test, various in-process quality quantification, and following SOP. So what I am going to say that European dye industry is today India also, we are focusing more on in-process testing. In compared to this, if we see the Japanese dye industry, Japanese dye industry also produce the same black 5 by the same manufacturing route, but they don't do any in-process testing. They are mainly emphasizing that if we take right quality starting material and the quantity and we do diazotization, the in-process result will automatically come as expected. So Japanese industry is mainly focusing on what is taken in the beginning. They don't do in-process testing. They trust their initial quantity and quality. Whereas in European industry or Indian industry, we also do the same, but we don't trust on our quality and quantity. That's why we have to do all this in-process testing. Whereas Japanese team, they have full faith on their initial quality and quantity. They don't do in-process testing. They consider that if we take this right quantity, quality, and follow the reaction parameters, final product will automatically come as a expected quality and quantity. So if they don't achieve this final quality, they don't start second batch. They think that there is something wrong in this or something wrong in operation. So they trust on their initial things. They don't need to check the in-process testing. So this is the difference between Japanese and European dice industry. Now, what is the difference between pharma and dice industry? As we all know that pharma industry required more pure products. Impurities are not allowed even in ppm level, because all pharma products are connected to human body. So the main product which are tested on human body, that only are allowed in pharma. Impurities are not allowed. They test their products quality by sophisticated instrument like HPLC, GC, mass spectroscopy, NMR, IR, all advanced instruments are required for pharma industry. Whereas dice industry doesn't require even pure product. 100% pure products are not required. Even sometimes byproducts are required and essential to match the desired shade of the die. And dice industry, they do quality testing by shade matching and TLC and HPLC. So this is the quality related difference between pharma and die industry. I will show you some example of dice industry and why pure products are not required and impurity are required, that you can get an idea. Here you can see that this first is the standard red die. Now the requirement is to produce the standard die. If by some problem a die shade is coming little more duller, in dice industry we can correct this shade by adding further dilute red dye or by adding yellow dye. So by adding either of this, we can make this similar to standard red dye. So this is possible in die industry. In pharma industry, this kind of mixing or mixing of impurities is not allowed or is not acceptable. Here is an example of multi-fiber dye. This is the fabric where here acetate fabric is there. This is cotton, nylon, polyester, acrylic and wool. Now in dye industry, particular in nylon, in multi-fiber, a black mixed dye required particular shade. So if impurities are not in sufficient quantity, this nylon shade is getting deviated. This is the required shade, but here we can see that this is slightly yellow or greener shade. Why it is? Because it has less impurity level, which I can show you in the next slide by HPLC graph. So by adding more impurity, we can match this nylon shade. The same nylon here dyed as a single fabric. So if you see that this is the HPLC graph of this particular this dye, middle dye. And in that, impurity is just 7.2%. So due to less impurities, it is showing greener yellower shade, 7.2% impurity. Whereas in other dye, the impurity is 13.2%. From 7, it has increased to 13%. And we can get the desired shade like this with more impurity. So what I want to explain that in dice industry, particular percentages of impurities are required to match the desired shade of a customer. Hope I am clear to explain you the methodology of dyes industry. Now the next segment is what is the best chemistry principle for best output. See, to get the best result, we need to optimize of reaction based on stoichiometric calculations to avoid generation of unwanted byproducts and control of side reaction. So what I mean to say that if we take 1 mole of one raw material and 1 mole of another raw material, we will be in normal condition able to produce 1 mole of final product. But if we take one raw material 1 mole and other raw material 1.1 mole, then 10% excess another raw material will generate in normal condition unreacted byproduct, or it will lie in the reaction mass unreacted. So that we need to avoid or optimize the stoichiometric raw material ratio. Now the other point is working with maximum possible and allowed concentration of reaction mass. What this sentence is that if we can work with say 25 or 30% concentration of reaction mass, we should work with the maximum concentration. We should not work with the 10 or 15% concentration of any raw material solution. This will help us to save the water and get the maximum output by using less water. The third point is effective utilization of available reactor or equipment capacity. This means if we have a reactor of 50 KL, we should work up to 35 to 40 KL of reactor capacity. Means nearly 75 to 85% utilization of equipment is a must to get best effective utilization of reactor. Occupancy of equipment and time cycle of steps required means we, as soon as the reactor will be empty, we should start the new batch and fully consume the available equipment for maximum productivity. So these are the best chemistry principle to get competitive rates or economics of your product to compare with the competitor. Okay, apart from above 5 points, there are other areas also which are equally important. Apart from production quantity, cost and market demand, there are other very important technical and technological area which are less focused but more important. See, these are our responsibilities to the society and the planet we live on. So I'll take one by one and then explain each in the coming slides. One is the environment protection. That means we have to reduce the waste and protect our environment. We have to also take the raw material process and equipment safety, means they should not damage, they should not create the pollution to the environment. That also we should take care. Safety and health of our co-workers and the manpower which are working in the factory, that is also very important and required. That the quality of your product, so quality assurance to your customer is also equally important for a better business organization. Registration and certification to the registration authorities, that is also must. Technological advancement means we should always work with the latest technology to get benefit of new invention taken in the globally. Business planning to avoid failure. This means that we have to plan our production activity based on advanced planning or yearly planning or quarterly planning with our customer. Supply chain management means how to produce and send the material and how to purchase raw materials. So all this will be covered in supply chain management. And the last thing is how Lonsan Kiri has implemented all above area and become a good manufacturing company, that I'm going to explain. Environmental protection, waste reduction. So see, there are three kinds of waste we are generating. One is solid waste, one is liquid waste, and the third is environmental, means air pollution. So how to reduce solid waste? So we can reduce solid waste by byproduct recovery, reuse of salt, safe disposal of waste, and incineration of organic waste. So by this 2 to 3 way, we can zero down the solid waste. How to reduce liquid waste? We have to reduce water consumption, reuse the water, and recycle the water which is generated in one process. If we can reuse that water in the second step, that we have to take care. Then multi-effect evaporator, RO steps, and zero liquid discharge. This should be the goal of any chemical organization, so that they will not generate any solid or liquid waste to the environment. And the air pollution, how we can control air pollution? So by efficient scrubbing, means all gas is generated in the reactor, we should scrub into the caustic or HCl or a specific scrubber, and monitoring the further discharge of outlet of scrubber and its NOx and SOx and everything, whether we are sending it to environment or we are controlling it. See, this is the raw material, process and equipment safety sheet. So how to check the powder safety of the raw material? So we need to check the minimum ignition temperature of raw material, bulk explosivity, burning and decomposition temperatures. These are the powder safety tests we need to check in the laboratory before using the raw material. For liquid raw material, we have to check the minimum ignition temperature for liquid, flash point determination to avoid any runaway reaction. For process, we have to check the DSC of raw material, DSC for reaction mixture, which are means when two raw materials we mix, and due to their acidic or alkaline nature, if there is a exothermic reaction, so before taking plant batch, we have to check its DSC in laboratory, external laboratory or safety testing laboratory. Reaction calorimetry, thermal screening test, see, all are process safety parameter which we need to ensure before taking a production batch. And regarding equipment safety for our reactors or our equipment, we have to check periodical boiler checkup, strength test, hoses and hose pipes and tools, thickness test for reactors. So these are the equipments. All these kind of safety things are required to protect our factory from any kind of accident. Now comes the other important, that is safe and healthy work environment. So how we can create safe and healthy work environment? So that we need to do the behavioral training, means we have to give regular training to our employees, so that how to work as per a standard operating procedure and not to violate any reaction condition or factory act. Also on the job training is also must. Then availability of personal protective equipments and their judicious use by all employees, that we need to ensure. Mock drills for firefighting, any kind of chemical spillage, gas leakage, that periodically safety department has to conduct in the chemical factory. And the regular medical checkup of the employees, and for specific chemical, if any hazard is there, that specific test also for employees we need to do. So by taking care of all these 4 areas, we can work with safe and healthy work environment. Now, as we all know that our business run on the customer's requirement. So what customer is expecting from us? So customers is expecting good quality product. So how we can produce good quality product? So we have to assure final product quality assurance, we have to give customer. But how we can get the good quality? So we have to check the initial raw material quality as per specification. Then only approved raw material from approved supplier we need to use in our manufacturing. After getting approved raw material, we, as I explained you in the German and the European and Japanese, we have to do the in-process parameter as per standard operating procedure we need to follow. In-process analysis we need to continue for all batches for consistency of quality in all products or all batches, that we can ensure. And then comes the final product. So in case of dyes, the final dye quality we can ensure. So if we ensure good quality, then the failure should be zero and customer will be happy. So we have to take care from starting from raw material in process till finished product and zero failure, then customer will be happy and he can get the quality assurance from our side. Then comes the government registration and certain certificates which majority customer is asking for. So we have to ensure our customer that our die or our product is not containing any restricted substances like banned chemicals. So that we have to regularly or periodically check and give assurance to our customer. Like banned amines, banned dyes and pigments, banned amine like parachloroaniline or aniline or paracracidine. So these are some banned amines which are not acceptable by customers. So that we have to regularly check in our finished product and give assurance to our customer. Heavy metals like lead, mercury, chromium. So these are all banned chemicals. So if we control all these hazardous and restricted chemicals and not allow, then we can get this kind of REACH, ZDHC, MRSL, GOTS, OCOTEX, Blue Sign. This kind of certificate we can get, and these are the required of major global customers. Now comes technological advancement. So what is its important? Technological advancement means we cannot do any pollution. So zero pollution should be our aim. Then one is pollution, another is best quality. So we should give the best quality to our customer. So that should be our target. How we can achieve best quality? So always advanced research we should continue for improvement of technology. For that, we have to have full-fledged analytical capabilities. And another thing is the customer requirement. So what our customer is expecting from us. So that is customer requirement. And improved shelf life means for how many time your die is stable. Like we all know that in the pharma industry, on each medicine it is written its manufacturing date and expired date. So it is normally 1.5 to 2 years. So the shelf life of pharma product is nearly 1.5 to 2 years. In case of dyes also, the shelf life is normally 1 to 3 years or 2 to 3 years, I can say. So by taking good quality raw material and all this taking care, we can improve shelf life up to at least 3 years for our products. And that is, we call it improved technology. Okay. Now, how to avoid failure in planning means how to run your business effectively. So we can start, we have to plan everything. So we have to do the market research for demand of our final product and what is the demand increase in coming years. So growth potential we have to study well in advance. Then we have to develop technology in such a way that you will be one step ahead than your competitor. Okay, so we have to technology development, and then you have to plan your production schedule that you can deliver your product on time to your customer. So for that, you have to purchase the raw material on time. Okay, and produce your finished good as per planning. After production, the die or finished good at your end, it should reach to your customer. So lead time we have to reduce, so that once it will be ready, it will immediately plan to dispatch to your customer, and timely dispatch to customer. And if you get its money on time, then again this cycle will continue. So these all are the planning part, and before you have to do the yearly, quarterly, half yearly planning to take care of all this development. Then comes the supply chain management. As we all know that customer is God in today's market. So we have to respect our customer. So how to fulfill customers' requirement? So we have to deliver our product on time delivery. Quality of packing means good quality packing or agreed quality packing or desired quality of packing, so that no leakage or no damage of material and spillage of material, that we can take care. Eco-friendly packing means as soon as possible we can avoid the use of plastic, use of degradable packing material like paper boxes. So those kind of agreed packing material we should use. In case of any delay, we have to intimate our customer in advance that by XYZ reason our dispatch is getting delayed. So they will take care with alternative sources, or they can wait for us. So if we take care of all these things, on time delivery, good quality packing, eco-friendly, then complaint will be zero. So with zero complaint, your customer will be happy. So these are all these are requirement of supply chain management. Okay. So now comes how Lawson Kiri has achieved all above 6 area and become a good reputed company in India since last 10 years. So that what Lawson Kiri did, that I'm going to explain you in next 5 to 10 minutes. See, Lawson Kiri started in the year 2009 and its production, and today it becomes a 1,000 crore annual turnover company with a full capacity of all effluent treatment and manufacturing capacities. So here, if you can see, we have the multi-effect evaporator to evaporate the water and get the distilled water. So this is our full-fledged effluent treatment plant. For safety of our employee and for the organization, we conduct regular safety training, on-site training, classroom training. This is also on-site training, and this training in the specific areas. So this kind of training is a part of any industry, and Lawson Kiri is following this very judiciously. Rainwater harvesting. So whenever in the full rainwater which is accumulated in the company, we collect in this pond, and then it's a pure water. So we reuse that water in our processes. Okay, so that's why we take care of water. We don't lose any water. Okay, effluent treatment plant with multi-effect evaporator, which I have shown here. This is our effluent treatment plant. So by taking or by working or treating all this kind of processed water, we are converting into its pure water. So that is also a must. Environment protection is our duty. So we take care of our environment, and we do tree plantation. We have a good green belt area. So we do Environment Day celebration and tree plantation every year and make our site very environment friendly. Now, how to make your production area very systematic and nice. So you can see here, this is our raw material storage area with racking system. So in small area, by putting racks, we can store so many raw materials. We have nearly 2,000 to 4,000 metric ton raw material every time available in our factory for continuous production requirement and customer requirement. This is our finished product storage area, product wise segregated, and these are the packed raw materials in 25 kg boxes, and one pallet is having 500 kg. This is another 500 kg. So we have nearly 2,000 to 3,000 metric ton finished product storage area, which is nearly 1 to 2 months our production capacity. This is our production plant area. So you can see the cleanliness and systematic reactors in production plant. This is the production plant work area where we charge all raw materials in. This is the ground floor area. This is the first floor area. So the main hall of all these reactors are on this floor. So from here we are charging raw material into the reactors, and you can see that there is no color contamination you will observe. So we have to keep everything very neat and clean to protect the environment. See, apart from all this production, we are also taking part in various government schemes of to encourage our employees and like that. So here you can see that every year we are taking part in government schemes for based employee and based improvement. So we have run one very every year we won the awards for various teams. These are the ladies and our employees have won very good awards. Apart from this, we are also giving presentations and lectures in academic areas and other organizations. So these are the pictures of our team members delivering lectures at ICT Mumbai and the CII function and other summits. So these are also we are taking part in it. So if we sit and decide that if we want to achieve this good practices, I think it is possible to achieve the good business practices, and we can do it if we decide to do it. Okay, so now let me check if I can show you one small video. So this is the rainwater harvesting pond. Dr. Tirth, can you hear the?
Yes, I can hear, sir. I can hear.
So this is our organization. It's during rainy season. The entire company's water accumulated in this pond, and we can reuse this. This is a pure water. Pure water. It is coming from the channels to this pond. So this was regarding my presentations. Now, if any questions, I would like to answer to any question. Dr. Tirth, please.
Yes, sir. Thank you, sir. Very interesting presentation and very good knowledge shared, and students have very good benefit about this, because we have in masters and bachelor course also dice paper in our course also, so they get very good knowledge. And students just not any question, but students are eager to ask this. Okay, sir, they wanted to visit industry, so is it possible if in your future, or at least after 1-2 months, if we will get in touch for
Yeah,
that?
it is definitely possible. Normally, we allow nearly 30 to 50 students in one visit, and what we'll do that we will allow them for a 1 hour plant round, and we will also explain them in classroom for around 15 to 20 minutes regarding safety requirements and what is they are going to see. So we will allow them to see the production area, laboratory area, so they will get a fair idea that how industry is working and what they are going to do in their future. So it is very much possible. So based on the corona, it was stopped since last 2 years, but now from last 3-4 months we have started to allowing the institutions for industrial use. So it will be possible. We'll make it possible for Parul University student also.
Thank you, sir. Thank you, sir, for delivering a nice presentation and nice talk to us. And thank you for getting time for us. And you are always welcome to Parul University. And on behalf of Chemistry Department and whole Parul University, I'm highly thankful to you. Thank you, sir. So we can conclude the.
Okay, thank you very much, Dr. Tirth. Yeah.
Thank you, sir. Thank you.
Okay.
Okay, sir.
Yeah.